Awesome. Okay, so I'll do the way we're going to run this is I'll do a quick run through a little bit about Schmidt Futures and sort of some of our top line work on why we've been interested in learning engineering, what we're doing. And I'm always happy to answer questions directly. We can drop my email in the chat. And then we're going to kick to Steve to talk about the incredible work that Carnegie Learning has been doing, especially and their UpGrade tool. And then from there, we'll go into Q&A. And I know folks have submitted questions before. They should feel free to drop them again in the chat just to sort of re-up them so that other people can benefit. And then I'll try to keep track, and then I'll call on people and I'll read it out. And if folks have anything to add, and then we'll try to run through as many of them as possible. So why don't I get started? So my name is Kumar Garg. I do a couple of different things at Schmidt Futures. My background is as a policymaker. I served in the Obama administration Office of Science and Tech Policy, and have been part of Schmidt Futures since its launch in 2017. And so we're just a little over 4 years old, and one of my responsibilities has been designing and launching and running the learning engineering program, which really focuses on how can we take the affordances of what's happening in computer science and apply them towards advancing the field of learning science and the application of that field. So we took the idea of learning engineering as a phrase, both from the incredible work that's happened at CMU to sort of conceive of the concept. And then I saw Bror on the thing. I also just took it because Bror used to talk to me about it, and I thought it was great. And so we have a definition up here of some of the ways that we sort of think about learning engineering. You know, just with a caveat that this is a little bit narrower than the definition as is generally used, which is we focus specifically on the intersection between the affordances of computer science, so computational architecture, computational methods, computational talent, as it applies to the advances of learning science. Obviously, learning engineering can have a range of other academic disciplines and how they intersect. And so we end up double clicking on one thread of it, even while recognizing there are other components as well. The other piece that I'll sort of say is the theory behind learning engineering, and the reason why we got interested is to be inspired by, where computer science is starting to have really big impacts in other domains of science. So if you look at something like computational biology, the past 15 to 20 years have been quite transformative. So that doesn't mean traditional biological research doesn't exist. In fact, it's going at all cylinders. But we are, by developing a set of new tools that allow much faster sequencing and thinking about, sort of big data approaches, researchers are now developing clues as to where to find the next cancer by actually saying, where does it pop up across, thousands, if not millions of cases. Similarly, we're now starting to have things like AlphaFold, where you're having, processes that used to take a huge amount of human effort get transformed by the application of machine learning. So the thread that we've really pushed on for learning engineering is how can we take those same approaches and apply them to understandings of human performance, human learning in a systematic way. And so we have three big threads of work when it comes to learning engineering. One thread of work is what we call platform instrumentation. So platform instrumentation sort of focuses on how do we take platforms that already have large numbers of users, a place like Carnegie Learning, and the fact that it's actually delivering a lot of education already means that we can actually embed within that a research enterprise that allows researchers to run lots of experiments quickly and develop, early intuitions about what might work, things that you may want to replicate in non-digital settings as well. But you could run lots of early experiments to sort of get a sense of what might be possible. And so we've been working with a number of platforms on what does experimentation at scale look like using digital learning platforms as the window into that. The second thread that we do is around what we call computational talent. How can we get folks who are getting technical skills in computer science and related fields and have more of them be interested in the domain of learning science and in the domain of education. And this is partly built out of our intuition that when we work with students, often coming out of school or coming out of PhD, often they don't have a strong intuition about what they could do in education that would use their technical skills. And so how do we make that more visible? And the final part that we do is, sort of computational methods. And so a lot of, we have been thinking a lot about, the analogy to something called ImageNet. So if ImageNet was a data set of 1 million images that help spawn rapid improvements in computer vision against that labeled data set, what are the labeled data sets that, if they existed, tied to some important benchmark in education, could drive that same improvement loop? So for example, a data set that used voice recognition tagged to early reading errors, could that allow you to create a much more at-scale detector of early reading difficulties that would allow much more active intervention by teachers, or similarly for writing? So that's been sort of our work. I think the reason I'm excited about this conversation is, the work that Steve has been doing around Carnegie Learning as at a large-scale platform, I think is really powerful in sort of talking about this idea of instrumentation. What does it take to take a platform that is delivering education to students and use it as also an embedded research testbed that both provides value to the platform itself, but also to the broader research community in seeing what is working. So we're excited about this as both something that is important to the research community, but also to the enterprise of education. And I'm happy to pass the baton to Steve to talk a little bit about what he's been doing.
Thanks very much, Kumar. I'm going to show a few quick slides that really kind of present, it's interesting in your framing of learning engineering, talking about the computer science aspect of it. My background is actually in cognitive psychology, and I'm going to talk particularly about how I think the field of cognitive psychology influences what we do in learning engineering, both in instrumentation and in experimentation, like with UpGrade. I call this from a Pittsburgh point of view because it turns out I'm going to talk about some quotes from mentors and colleagues of mine, and it turns out they're all from Pittsburgh. Carnegie Learning is based in Pittsburgh, as is Carnegie Mellon University, for people who don't know. So there's a little bit of local flavor for me there, but it's applicable to the whole world. So for people who don't know Carnegie Learning, we did start at Carnegie Mellon University as a collaboration between psychology, computer science, and the Pittsburgh Public Schools. So we had a very, for a psychology department, a very technical approach. For a technical computer science department, a very applied approach, accepting of learning science, and then very applied in terms of working with the Pittsburgh Public Schools right from the beginning, because the understanding was that we really wanted to make an impact in the real world. And that was, 30 years ago. I was not there at the beginning. I haven't quite been with it for 30 years, but 20 something years, let's say. So I was part of the research team at Carnegie Mellon and helped spin off Carnegie Learning. We're probably best known for our math products. We actually primarily deliver a blended core curriculum for high school and middle school. The software is called Mathia, and the text we call MathBook. We also have Mathia Flex, which is a software supplement to other curricula. And we have a program called Zorbits at the K-5 level. And then we also have programs in English language arts, including Fast Forward, which came from Scientific Learning, really interesting product based on the neuroscience of reading, Mirrors and Windows, and products in world languages and computer science and other things. But mostly I'm going to be talking about math. That's where our kind of origin is and what a lot of the work that I'll be talking about came from. I'm going to start, I said some quotes. I'm going to start with a quote from Ken Cadinger, "The student is not like me." When we first started, Ken was a graduate student a couple of years ahead of me in the psychology department. And he tried to get this to be the mantra of our group. He really wanted everyone to kind of keep this in mind every time: the student is not like me. And I may not have appreciated it enough at the time, but over the years, I appreciate it more in the sense of being really explicit about why we're collecting data in the first place, right? And in some ways, like, the biggest mistake that a lot of educational technologists make is in relying on their intuitions to help students, right? Your own intuitions and your own experience in education, which everyone has, are valid and important, but you always need to test them against data, because in fact, the student is not like me. Most of the people who are in this field come from backgrounds where they probably were strong in math and science and computer science, maybe didn't go through the same kind of struggles that a lot of the students that they're trying to help have gone through and are going through, may have very different backgrounds and very different interests in students. And so essentially, data collection in some ways is a barrier against trusting too much that your own insight and intuition is a good guide to what's really going to work for students. There's a related concept called expert blind spot that Ken and Mitch Nathan and Martha Alibali coined, which is kind of lasted. A lot of people talk about expert blind spot in the sense that the more you know, in some sense, the less insight you can sometimes get into students, because you're so far beyond experiencing the kind of confusions and initial thoughts that they have that it's really hard to put yourself in their place. But again, that's why we collect data in the first place, is as a check against that. There's also a strong equity angle to this, in recognizing that in terms of backgrounds and interests, particularly, that if you want to reach the students who you want to reach, you may need to understand that their backgrounds and interests are not like yours, and you may need to do something that that is not necessarily in line with what you would do for yourself. The corollary to this is one of my favorite quotes from field testing. Al Corbett, another co-founder of Carnegie Learning, came back from one of the first field tests of cognitive tutor on math software and said, neither the software nor the students performed as expected. And that's been the experience all the time. You have good expectations and intentions, but every time you bring it in front of students and teachers, if you are observing well, you should be learning things that were unexpected. Even after 20-something years, we're still always learning things. Second quote is from John Anderson. John, also a professor of psychology and computer science at Carnegie Mellon. And John's kind of day job is a model called ACT-R, which is a model of human cognition in the large, about all aspects of learning, memory, and performance, perception, other aspects of cognition. And ACT-R is kind of the basis of our approach and the way we think about learning. And I think one of the most important statements that's most relevant to what we do and what other people do in education is learning on the large scale is composed out of learning on the small scale. And what John means by that is when you're trying to when a student or a person is trying to learn or complete a complex task, what your brain is doing is breaking that task into smaller components of cognition that help you navigate that task. And essentially, from an educational perspective, the thing to recognize is that the brain's a learning machine. It's not a good question to ask if students are learning. They're always learning. But the question that you want to ask in learning analytics is, what did students actually learn? And sometimes what they learn is not what you think they learned or what you intended them to learn, right? Brain can't help but learn. But in an educational context, your task is to construct things such that the brain learns what you're intending to for them to learn. As illustration of this, I'll talk about like one of the fundamental elements in our learning analytics, which is called the learning curve. And this is really just, again, a fundamental statement about learning. What is learning? Learning is that when you do things, you get better at it. If you're learning, when you do things, you'll get better at it, right? The question is, what are those things that you're doing? What are you actually getting better at? An illustration of this in this learning curve, we asked students, and this is over about 10,000 students, received word problems, and at least one part of their task was to translate the word problem, which embodied a linear equation, into a linear expression as circled on the screen here. And what we're looking for in a learning curve is over each opportunity, and an opportunity is a problem in this case, how likely are students to get it correct? So over this group of students on their first opportunity, the first time we gave them a word problem like this, on average, they do 25% correct. Second opportunity, there's not really any improvement. Then there's a big leap on the third opportunity, and it continues to kind of go up from there. So that's good. That's evidence of learning. Students are getting better as they do more of these word problems. But there's a strange thing you would expect from the psychology that that students would get better at monotonically, that there wouldn't be this flat no learning between the first and second problem, and then suddenly a jump in learning to the third problem. And so that's strange, and it's indicative that what we're measuring is not actually what students are learning. And it turns out that the explanation for this data, this central graph, is the same data, and this is the exact same data in both of these side graphs. It's just carved up in a different way. So we were giving students sort of, you can think of them as randomly selected problems along each of these opportunities. And some of those problems involved an increase in quantity or a positive slope. Some of them involved a decrease in quantity or a negative slope, right? Mathematically, that's the coefficient of the variable in the linear equation, the sign of that coefficient. But what the data shows is, from the student's perspective, they think about positive slope problems, let's say, where you're making money, differently from negative slope problems, like problems where you're spending money. And we see that because when we graph just the positive slope problems on the left and just the negative slope problems on the right, we see smooth learning curves. So what that means is, from the student's perspective, when you look into like how the students are thinking about these problems, if they have experience with a positive slope problem, that will help them solve the next positive slope problem, but it will not help them solve the next negative slope problem. They need experience with negative slope problems to get better at solving negative slope problems. And that's kind of what's going on in this flat thing. If it's a positive slope problem for the first problem and a negative slope problem for the next problem, there's no transfer. Students haven't learned anything that's applicable to that second one. But the third one's a repeat. So the third problem is either their second positive slope problem or their second negative slope problem. At least it's likely to be that. And so that explains the shape of this learning curve. And what it really is a discovery about how students are thinking about those problems. And it's a discovery that's essential to building effective instruction, because what you're always doing in education is inferring what the student knows from what the student does, right? And whenever the student does something, you have to think about what that indicates, how that bit of knowledge that the student is using to solve that one problem could be applied or will be applied to another set of problems. So a lot of the questions that we ask, within the math domain is, if I see a student correctly solve a problem like 3x equals 6, very simple equation, does that mean that they can solve 3x equals 7? Well, maybe, but maybe not, because one way to solve 3x equals 6 is just to recognize that 3 times 2 is 6. Right, which is an easy recognition, whereas saying 3 times what equals 7 is a much harder problem. So just because they solve that one doesn't mean they can solve the other. And similarly with the positive and negative numbers, if we see students solve 3x equals 7, that doesn't necessarily mean that they'll be able to solve negative 3x equals 7, or things like negative x equals 7, where the coefficient, the number there, because of mathematical notation, is not evident. So learning curves help us answer these questions. What are students actually learning when they're going through problems? And how does that learning transfer to other problems that have some similar and some different characteristics, which is essentially what you want to do. We also use these learning curves to differentiate students. So as a process, we're always trying to make the learning curve steeper. We want students to learn quicker. And what we can do, shown in this graph, is we sometimes kind of understand the student's learning trajectory and are able to respond to students who are very fast learners, mastering very quickly, versus students who might be in the middle of what we call productive struggle. So they are making errors, asking for hints, but making good progress towards mastery. And then students who are unproductively struggling, flailing, and those are students who we really want our system to do something different with, because they're not on the path to mastery. Okay, next quote is from Herb Simon, who coined the term learning engineering. And Herb had this knack for saying things that seem really simple, but are in fact really profound. And one of those examples is, he said, learning results from what the student does and thinks, and only from what the student does and thinks. The teacher can advance learning only by influencing what the student does to learn. And this is phrased about teachers, but it applies equally to educational materials, including software. What you want to do in software or in any educational materials is to give students experiences, things to think about and things to do that help incorporate new knowledge into their current understanding, and that build knowledge in a way that generalizes to new tasks and situations, just as I was talking about before. And then also that makes students think about the knowledge components that are crucial to understanding the domain that you really want students to become skilled in. Okay. So as an example of this, hopefully we'll see this, just as an example of the kind of tasks that students do in Mathia. Here's a fraction manipulative where we're using fraction bars to illustrate fraction addition, having students drag over these pieces of fractions so they understand intuitively that the whole on the right here is the sum of these pieces, but they can't really measure how big that whole is until they construct common denominators. And then we have students relate the fraction bar experience to the kind of more mature procedure that they will execute for adding fractions, right? And so the idea is to build the conceptual knowledge underneath the procedure for adding fractions so that it will generalize appropriately. And you can see as students work through it, up here is what we call the scalometer. Each of those individual knowledge components, each of the steps that students are taking along the way to solve a problem are tracked within the scalometer. And we use that to judge mastery and to pick problems that are appropriate for each individual student. But how do we, as Herb Simon said, like, how do we know that that experience that we're giving to students is the best possible instructional model for fractions? And this is a question that came up fairly recently when we were doing revising our models for fraction addition, and we had a number of different designs for models that help teach students about fraction division, similar to the way that we do that. And an appropriate approach to that is to run a test, run what they in the software world they call an A/B test. In the social science or cognitive science world, we might call it a randomized field trial. And so what we want to do is present some students with this fraction bar model on the left, some students with the fraction bar model on the right, and determine which one results in better outcomes or better learning. And so we built this system called UpGrade. This is a simple screenshot of the UpGrade dashboard. You can go to upgradeplatform.org to learn more about it, or certainly ask me more questions here. It's a free and open source web service that runs independent from your educational app. Although we're using it with Mathia, it's available to use with any educational application. It does not store student personally identifiable information. So we're trying to keep all that personally identifiable information in UpGrade itself, and I'm happy to answer more questions about how that works. Some of the features that we really focused on that are unique, or at least much more important in the educational context and in many other contexts where you're doing software A/B tests, are group random assignment. So if you have these two fraction bar models, for example, you probably want every student in a single class to either have model A or model B. You don't want some students in the class to have A and some to have B, because if they're calling the teacher over for help, the teacher's first question is going to be, well, which fraction bar model are you using? And let me remind myself how that works. It's just much of a burden on the teacher, as well as potentially unfair to students. And so you want to do what's called group random assignment, which is giving all the students the same version in one class. And then you have, what you're doing is, instead of randomly assigning students to get a fraction bar model, you're randomly assigning classes to get a model, and each student follows the model chosen for their class. And we can do that at the school level or the district level or any other kind of grouping that you want. And so that's managing that over time is part of what UpGrade does for you. The other thing that it's concerned with is adaptive software. So in a lot of the experiments that we've done in the past and that we envision doing in the future with UpGrade, in adaptive software, students will be doing different things at different times. So if you think about the time when students are learning fraction division, one student in a class might be doing it on Monday, and the next student doesn't get to it until Friday. So effectively, that experiment starts at different times for those different students, and UpGrade helps manage those kinds of things. Okay, so that's all I've got for now.
Awesome.
I'm happy to answer questions.
So folks should feel free to keep dropping questions in the chat, and then I've got folks helping organize them. So I guess one thing, and then I'll start to go to the actual questions, is Steve, my experience has been that this has been harder than people expected, as in most ed tech. So when I sometimes explain this to other people, they find it surprising that most ed tech platforms do not, generally as a matter of course, have what looks like UpGrade. Because you can imagine, like, oh yeah, obviously you should have an internal A/B engine that tests your different learning strategies against each other so you can continue to improve. But that's actually not the status quo in most instances. So do you want to just give a little bit on, like, what technically did you have to do to convince your engineers and to graft on top of the platform this engine? Just on a, like, did it take you one engineer? Did it take you two? Did it take, like, what were the things you had to do to get it to actually work for you? And now I'm curious as to your answer as to whether it's like, it was so much work, no one should do it, or whether it actually is something that people can systematically actually build into their technology in a way that gives them. So I'd be curious, because you went through this process of like implementing this on a live platform that has a large number of users.
Yeah, so there are a number of factors that make experimentation in education difficult that we could talk about, but specifically, I think about like instrumenting an existing platform to work with a tool like UpGrade. It's really, there's a key kind of mentality that you have to have, which is kind of this empirical mentality, which is kind of saying, like, we're going to do A, but we could have done B, right? And so from Matthew's perspective, like, one of the things that made it relatively easy for us is that the way we think of the world is in the sense of we're going to give students an activity to do, right? There's a place in our code where we decide what you just finished activity 1, and we have a choice, what's activity 2 going to be? Every bit of adaptive software has that, right? Some level, right? And what we need to do is instrument that presentation of activity 2 to be able to say essentially, okay, let me check with UpGrade and see if there's an experiment running that's relevant to the presentation of this activity 2, right? And if there is, UpGrade responds and says, yeah, and you should give the student 2A or 2B or 2C or whatever. One of the things that we've done architecturally in UpGrade is try and make all the complicated logic about why a particular student gets A or B lives in UpGrade. The platform implementers don't need to worry about that. But they do need to have the mentality of instrumentation. The best leverage that you get is if you have a small number of what we call decision points in your application, right? If you know there's a particular place where you may need to make a decision about what educational activity to give, that's where you're really leveraging UpGrade. And it's not necessarily also in the content of those, like I give that fraction bar example, but it could be equally motivational messages, layout of the screen, whatever, as long as there's a place in your code that's kind of powerful enough to insert a decision to drive the code in one direction or another, that's where you're going to get the most leverage.
That's great. Why don't we go to the question from Bror about learner state? Bror, do you want to ask your question?
Sure. I mean, at its most general, it's like, how do you include data about what is in long-term memory of a student, right? And that's not just academic, but it could also be identity questions or motivation, could also be context, right? Like if you're from the UK, maybe you should get a problem on cricket rather than a problem in baseball. So there's lots of like long-term memory stuff that could end up influencing what works for whom when. And so I'm curious, does UpGrade, or do you see how that data can get added in to help you with the final analytics of what worked for whom when?
Yeah, really good question and a hard one, Bror. But I'll just give you a framework for how I think about these kinds of things, right? So essentially what you're asking is like, how do we take into account personal factors when running an experiment and when providing instruction, right? And I think there's kind of 3 things that you can do, and I'm going to ignore the question about like where that information comes from, how you know about the student's identity or what's in their long-term memory and stuff. Somehow, let's assume that you know that, right? So if you're running an experiment with a system like UpGrade, one time when you might want to know some student information is at the time of random assignment. So the kind of classic experiment just says, I'm going to randomly assign a student to A or B. I'm going to flip a coin. I'm going to assign students to A or B, right? A different and perfectly valid and statistically more powerful version of random assignment says, oh, I'm going to pair students up or groups up based on characteristics that I know about them, like how well they've done in prior activities related to this or something like that. Pair the students up so that ensures that, and then flip a coin between that pair, right? So that gives you just a better matching between group A and group B. You're not depending on the coin flip entirely. You've kind of matched them on factors that you think are relevant. So that's using those personal factors at the random assignment time, which is one way you might do it. And I'll shout out to Dennis Newman. I might be on here, but he's got some strong ideas about how to use that within UpGrade, which is not a capability we have. It's one we'd like to add. A second way is when you're delivering the instruction, you want to use some information that you know about students, right? That's not about the experiment. that's about the instructional policy, like the adaptive instruction, right? So the example in Mathia is we at least know something about what students have done in the past in Mathia, and we use that to pick new problems and new activities for students to do. And then the third place is in the data analysis, right? So you might, you can run the complete experiment without knowing a whole lot about the students, but then in your analysis, you can look at, oh, it turns out that students who did really well on the pretest responded to this intervention, and students who did really poorly on the pretest responded to a different intervention, or other characteristics that you can look at in your data. So that's a framework for at least thinking about those things.
Awesome. Let's keep going. Let me next call on Dylan, who asked a question about concurrent experiments. Dylan, you want to ask your question?
Thanks, Kumar. Steve, does UpGrade currently support or plan to support multiple concurrent experiments? And if so, does it do so in a way that makes sure that all assignment is orthogonal? That might be tricky given that some experiments might be at the individual level, some might be at the group level, et cetera, but I'm interested.
Yeah, another good question. Right now, UpGrade supports concurrent experiments sort of at your own risk, right? It doesn't have any knowledge about what experiments might. Sometimes having orthogonal experiments is just fine, right? So, because they don't interfere with each other. Sometimes they do. UpGrade doesn't have that kind of information to be able to manage that. But that's definitely something that we'd love to think about to add to it. I'll say that in the special case of like factorial experiments, that's kind of on our short list. So a factorial experiment you can think of as multiple experiments that are kind of pre-designed to take into account that orthogonality. And that's definitely something that we want to do on the roadmap.
Yeah, and I wonder how places like Duolingo, when they've got 200, 300 experiments running at the same time, how they're managing for it. But it's a great question. Corin, could I call on you to talk about your question around both PII and privacy?
Sure. There was some comments in the chat that were talking about the value of context and thinking about, like potential demographics and elements that we can bring in to understand learner context. Just thinking about how you view balancing those kinds of contextual questions with more ethical concerns and PII protection and elements like that.
Yeah, right. So our first principle with PII is to only collect data that you really need. And if you think you need it, make sure you really, really need it, right? So the less that you know about students, the less of that personally identifiable information that you have, the less risk that you're undertaking. And that's, independent of UpGrade, but true of UpGrade as well. So that's that first element. The second one is, I think, part of my answer to Broer's question is relevant, is you need to think about when you're using that information, because that determines like who needs to have access to it and where it gets stored. So if you're just using PII, like you get, various bits of demographic information to analyze your data at the end. I don't mean to minimize that by saying just, it's an important thing to do. But if that's what you're doing, then your data analysis team needs to have that data, but no one else along the way, right? Your application doesn't need it. Your experimental design people don't need to have it. And so you're limiting the scope at which that information is being used. And we sort of like push that through to UpGrade in the sense that where UpGrade itself, since it's acting as an independent server, doesn't get any PII, and basically we're doing that in the simplest possible way right now, which is any sort of identifiers, including demographic information, but student identifiers, school identifiers, all those things get anonymized. Your application may and probably needs to have identifiable information about students in order to, for example, produce reports for teachers. But when that information is conveyed to UpGrade, you substitute an anonymous ID. And so UpGrade is able to do its thing, but you need to maintain some sort of mapping table between your identifiable student ID and the anonymous ID that UpGrade works with. And that's the same kind of process that we use like in data analysis. So the truth is, like, what you want to do is you take that same sort of mapping table. If you're using it in analysis time, you take the identifiable information, associate it with the data from your application, and then you throw all that away. And so then you have a clean data set that doesn't have those student identifiers there, at least to the extent that you can.
Amazing. Next, let's do Catherine, who had a question around context as well as generalizability, which I think tags to some of the questions we've gotten already. Catherine?
Hi there. Yeah, so just curious about your thoughts. Clearly we know that learner context does matter, and we should be capturing that and studying it to, evaluate learning effectiveness. I'm kind of Pittsburgh trained too, so I totally understand the prior knowledge angle. But as a field, there's a lot of talk about we do need to understand this context. We need to systematize it. So my question to you and to everyone is, are there a handful of kind of frameworks or useful generalizable ways to think about context that we could kind of systematize as a field so we can start gathering data on them together and start swimming in the same direction there?
Yeah, really good question. So that's sort of somewhat about aggregating the results of these experiments and understanding the context that they took place in, and how we socialize those results in a way that we can do that. So like the EdTech Efficacy Project is working on in that kind of direction. And I'd love to help. Like the one quote that I left out, which I should go back to it because it's one of my favorite. Alan Newell wrote this famous paper called "You Can't Play 20 Questions with Nature and Win," right? And really, that's about this generalization question, right? Although I'm totally a fan of running experiments within UpGrade, it's like playing 20 questions. You can't just keep saying A or B, A or B, A or B, and get anywhere. Eventually you have to build theory, right? And that's what you're talking about, is what the theory involves is understanding why did A work better than B, and how does that result generalize? If you really know why, you know how it generalizes to other contexts. I don't have any great shortcuts for getting to that insight, but I totally agree that, like, at least part of what we need to work on is socializing that knowledge.
That's great. Let's go to Jim Connor, who had a question around data collection. Jim? Maybe Jim is here or not here. I'll come back to him. How about we go to Aaron Kessler, who had a question around analysis and reporting. Aaron?
Hey, Steve. Hey, Kumar. So one of the things that I wonder about is, Steve, you talked about sort of Akhtar rooting a lot of this work, and that's true for sort of the data analytics community in the Pittsburgh frame. I'm curious about what generalizes out of this to people who are maybe employing other learning theories as their foundational starting point, and how they go about, and we go about thinking about what is generalizable from both the platform and data collection processes, but also then the sort of what we've learned from your experiments that may apply elsewhere.
Yeah. So we tend to kind of like what I talked about with John Anderson, and that kind of thread from the CMU world is a very kind of John calls it the decomposition hypothesis, right? We're decomposing kind of large things into small things. And there are alternative kind of models where you're looking more holistically at things. But I think you're still ultimately you're making a transfer prediction, right? That's what you should be doing, right? Is saying, based on this experience that I'm giving students, what can they do in the future, right? That's what instruction is about. And if I'm giving them an experience that I sometimes, and I think a lot of other traditions take the goals as less fixed, right? So the more you open up the task to students, the more you're enabling students to perhaps learn different things because they're approaching the task in different ways. From our perspective, I would say they're encountering different knowledge components. And we sort of frame that as saying, oh, well, that's a problem because we're not teaching students what we're intending to teach them. But the alternative way to say it is, well, that's fine, as long as we know what they're learning and that we're able to say that, hey, you know, they're on a path where they've learned, you know, two kids have learned different things, but they're both valuable things to learn. And I also know ultimately how to build on top of that. So to me, that's part of the merger of the two perspectives. Is it's still about being more explicit about what students are learning, but it may be less about, there are definitely ways to be kind of less explicit and directive about what the goals you want students to learn are.
Awesome. Why don't we go back to Jim, who I think is back now.
Mute myself there. I did. In fact, I'll put my video on too. So thanks very much. Well, look, we're in a reading program and we're trying to set up a data tracking or collection based on the way kids learn to read. How many times a week do they get the lesson? Is the lesson in class or is it remote? We do both. And are the parents involved? These are all a range of variables, frankly, that we are struggling with how we're going to collect them, and then what periodic evaluations we can do to show efficacy or progress in learning to read. Any comments, any insights would be most welcome.
Yeah, I mean, at a very high level, like I can't help you with collecting the data and instrumenting it, you know, in the sense, except to say, like, I totally sympathize with how hard that can be. But building a model, I think, like, there is a general way in which you can think about what you're really doing, right? Which again, like, I think about this transfer context, right? If your theory is that that reading slightly above your reading level, or reading context where the student has more agency, so they've picked something to read that's in their interest area that's relevant to them. Whatever the theory is, those are the kinds of contexts and elements that you're coding there. And you want to just kind of be able to compare whether students who have that element versus students who don't. Does one group of students learn more than another? You need to also think about the key element of random assignment and UpGrade is that what random assignment lets you do is essentially assume that the one thing that you're changing is really the only difference because everything else is random, right? You don't always have the opportunity to do a random assignment experiment like that. And then you need to think about, controlling for all these other factors.
Yeah, I think that's the challenge. We have to find a control group that gets no attention whatsoever, and then compare that to the group that does get attention, if I could say.
Well, I do have a recommendation for that. So there's a lot of things in education where you feel like, I don't want to hold something away from students, right? And one experimental design that you might consider is a crossover design where group A, it's not like A gets it and B doesn't. What happens is A gets it in January and B doesn't, and then B gets it in February and A doesn't, right? Mm-hmm. So overall, over that 2-month period, they're both getting it, right? But you're able to compare the two different time periods to see the effect.
I don't want to eat up all the time, but does A get it in both January and February, or does A get it in January only and B only in February?
Yeah, there's a lot of complication, right? So part of the answer to that has to do with whether you think there's a carryover from what A did in January to February, right? So if it's the kind of thing where if I'm giving you candy every day in January and then I stop giving you candy in February, that actually has an impact different than if you never got candy, right? Yeah. Like, you're like, where's my candy? And you're less motivated, maybe. So yeah, there's no general answer for that, but yeah, it's something, that's the way I would think about that.
Yeah, I appreciate you giving me this much time. If anybody would like to offer any suggestions offline, jconnor@startupreading.com would be great.
Jim,
we are struggling.
Jim definitely added to the chat, and I'm sure people can follow up. That'd be great. Let's do Joshua Weiss, who had a question around, what is there certain formats that are more optimal for A/B testing?
Yeah, thanks. Can you hear me okay?
Yeah.
Yep. I just had a question about implementation. Maybe this is getting too far in the weeds, but understanding what types of data play best with this. I understand it's somewhat about setting up an environment, but it's not clear to me how rich the media could be, where you could be running these kind of A/B tests. Could it be video or audio, MP4, 360 video? Just an idea.
Yeah. The way to think about it is so UpGrade is not getting involved in your media or anything that you're doing kind of at all. All it's really doing is at the point in your application, that decision point when you're deciding, like, should I give student experience A or experience B? It's calling out to UpGrade, and UpGrade's returning a code that could literally be A or B. And then the application, if you have a video or you have a, audio stream, or you have a manipulative or whatever corresponds to A versus B, that's up to your application to kind of implement. Does that make sense?
It does. Thank you.
Let's do Jack on open learner models.
I'm not an open learner person, but I've met some at conferences, and I'm curious what perspective they would have on UpGrade. If you let, you do have scalometers, have had it in Carnegie Futures for decades now. But how would those things interact, or is that just apples and kumquats?
I wouldn't say it's apples and kumquats. So you can choose to open up the learner model or not. You could run an experiment on that too. So that's one of those things that we've thought about, right? Is what's the impact of giving students insight into what the software thinks they know, right? And agency over that, right? And that's some of the open learner model people might be interested in doing that. So UpGrade could certainly enable that kind of experiment, but I don't think UpGrade on its own favors one or the other approach.
What I have in mind, and it's fuzzy thinking, is imagine that the statistics or whatever representation UpGrade is accumulating is actually visible to the students that it's accumulating them about.
Oh, yeah, that's an interesting idea, Jack. So you would be concerned, you would possibly be concerned that that would influence student behavior in a way that wouldn't have happened if you weren't opening that data up to students.
And from the point of view of people who advocate open learning models, that's a feature rather than a bug. From our point of view, it's a headache.
Yeah, but I would say, like, I don't think anybody has an objection to opening that data up, right, in an aggregate fashion to the world once the experiment's done, right? And that's the intention, right? That we were talking about before about socializing the results of the experiment. During the experiment, it's potentially problematic because it could influence what students do in a way that complicates the interpretation of the experiment.
Especially what I was thinking is making the student's own data visible to the student. What the system thinks it's looking at the student.
Well, but the student's only in one condition. So the student, in our world, so they do have a scalometer, we have other data displays. So students will get their own information. What they don't know is any indicator of what would have happened if I was in condition B.
Don't you support within subject experiments?
Not yet. Well, sort of, but not yet, really.
Oh, okay. That's my favorite.
But yeah, that's an interesting. That's a good point too. Yeah.
So I'm going to close it off here with just a few thank yous. I think, Steve, it might be useful whether we do it on the chat or something else. We got a bunch of questions where people wanted to learn more. I think all of UpGrade is not only demoable, but also is available. People can download it, try it out, all that stuff. So we'll share information on how folks can check this out. It's openly available, and I don't know if you guys have put those things out, but I wanted to just sort of thank you for taking the time to both talk about this and for doing this in a way where others could, try it out, use it, let folks know. I know at least a few people who are on who have actually taken it and embedded in their platforms with quite interesting results. So I think I would encourage people to take it out for a spin and then give Steve feedback on how the open tool can continue to develop. And I wanted to thank everybody for what are pretty incredible questions. I think Steve definitely got pushed, which I like.
Tough questions.
both on like new things that they should build, as well as I think the reason I'm excited about this is I just don't think that many of these kind of open tools exist. I think researchers in general are having to design experiments from scratch with almost no tooling at all. And so even though this is the beginning, I think there's a lot more to be done, and I'm encouraged with that.
Yeah, and I'll emphasize that too, that we're really, like some of these ideas are great improvements. We're still in early days here. And so if you want to get more involved and have ideas about how to make it better, features that it doesn't have, definitely let me know.
Yeah, and we're eager to, continue to push the field and support as much as we can. And then finally, I'll just say, we've got a learning engineering Google group that is pretty active. And so folks can continue the conversation there on existing tools and new tools. We've certainly been encouraging there. And if you're not a member, but you're joining this conversation, we can definitely pass along information for how to join. Steve, any last comments you want to make based on the conversation or anything you heard?
No, just to thank everybody for coming, and upgradeplatform.org is our website. Kumar, you mentioned a demo. We're actually like on the cusp of releasing like a demo environment that will help people kind of play with a version of UpGrade using a sample app to just get a feel for what it does and what it doesn't do and all that stuff. So look for that soon. And thanks very much.
Yeah, and I encourage everyone who's part of Tools Competition and wants to do instrumentation to check it out as well. Thank you.
Thanks.
Bye, everybody.